Hello, welcome everyone. Today I will present to you my version of an attachment for nuts, which is threading on a lathe. My version of the tool is a universal sleeve for mounting on one side M12 nuts and on the other side M16, and the smaller ones will have an adapter screwed onto this side with M12. Why this side with M12? Why? I will explain later. The nuts I have come in different diameters and thicknesses, so the adapter is necessary. When it comes to the very beginning of the work, you need to buy the nuts, so you won't be surprised later, and only then get down to it, to work. As for the very beginning, we obviously start with creating a shaft, forming the guide. For me, it's a shaft on an MK4 spindle, but I might not show how to do that. Anyone can make such a shaft for themselves. Later, let's get started on the bushings. Here, of course, is just a short film clip. The bushings should be drilled from the smallest diameter, then to the largest one. In my case, it ended with a drill bit of 29mm in diameter. The rest was expanded using... My diameter is approximately 62 mm. That's what I had. This is C45 steel. Here, I'll add right away that it's worth to use a better material. It turns much nicer. It has a finish. In short, it looks shiny. It looks nice in the end. Very nice. Of course, we drill slowly. We use drilling fluid, we remove the chips. There's a lot of fun to be had with this. I didn't record the amount of chips, what came out of it. However, I think that the hole was drilled for about 2 hours and then another 2. Bored. This footage is of course a simulation of that environment and the drilling. I didn't record this part. However, anyone who has ever drilled or turned something will obviously manage it. In the end, it looks like this. So we have the bushings we have on one side, the recesses. These nuts should fit in there quite well. It's tight. If you care about accuracy, then of course you have to do it that way. On the milling machine, we will mill out the guide. For me, it's a milling cutter M10. It's about 12 cm long. We also mill very slowly, of course. I went somewhere, not quite sure, branded cutters, so I haven't removed too much material for now. And if everything fits nicely, meaning the road, the sleeves, of course, you need to gently use sandpaper there. In my case, even the grinders, because here and there it was a bit too thick. It was a bit too thick. Everything will start to fit together very nicely. Before milling, this groove, you actually make it like this. This kind of syringe, when you press it against your hand or leg and pull the plunger, it's very tight. It sucks in air. What's next? Well, all of it. This device is quite heavy. In my case, it weighs approximately about 5 kilo. It's really a solid piece of steel and robust, so it will later prove beneficial when guiding of the bushings. Secondly, there are quite large forces acting on the lathe, so there's no point in saving on material. In my case, I didn't roll that material. Also, to reduce the weight of this component, of course you can. However, I found that losing 3 to 4 mm in diameter doesn't significantly affect anything, and thanks to that, the whole component is much more durable. In diameter, it won't significantly affect anything, and thanks to that, the whole component is much more durable. Now you can see it installed, tools M12 and M16 on both sides, and of course they have cutouts, they rest on the edges. They are recessed 0.5 mm inward. Here we can see that it even managed to roll out. There are still no screws here, centering and mounting, and it looks like this, more or less like that. Now I was just thinking about exactly how to carefully drill these guide holes. I still don't have a rotary table. This will be the next project. I designed a gauge like this. For 3D printing, this is a kind of bush. We can see the guide screws on the sides leading to the die. From the front, there will be holes for the adapter for other diameters. This is this side, holes for the adapter for other diameters. This is this side, from M12 for assembly. After printing, it looks like this. This is actually white PLA. Everything printed out very nicely. It fit perfectly. This is how it looks on the part. So we have an M5 guide for the drill, for the pilot holes, if you prefer. And after placing it, and we can use a corner bracket, set everything up nicely. Insert, center drills, and we're ready. And now finally how it works. So from the scrap I had M16, a rod was prepared for threading M12, which has a diameter of 1.83 exactly. And this is really the first video. So which one? That I made from work. There was no trial. The part is mounted to the corn mill, mounted. Attachment, and we gently move closer. The pin. Now the thread will catch, and we can see that even the dock didn't slow down. Everything is going smoothly. Smoothly, nothing broke, nothing... It didn't break. So we stop at the threading. The resistance allows us to keep it properly in place. Left turns. We're moving away. And the thread is ready. In a moment, the gauge nuts. And in the end, the part is ready. My attachment thread's about 10 centimeters at most. Of course, to use another tool, you need to unscrew this one. Rotate the part, screw M16. Maybe I'll record it later. I still don't have the adapters I mentioned. These will be steel discs for M10 and M16, screwed from the front with 4 screws. The finished thread came out roughly like this. I'll be honest, it's perfect. I really didn't expect it to work so smoothly right away. It's done. So I invite you to leave comments. Overall, the part is a bit time consuming, but it's worth it.